Good morning, everyone. Today we're going to be learning about section 2.2, linear relations and functions. I know we usually don't use videos like this, but today is a special occurrence. So let me open up the right format here. Okay. So linear relations and functions. I'll start here with an equation such as x plus y equals 5. It's called a linear equation. A linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. The variables may not be multiplied together or appear in a denominator. So they may not be multiplied together or appear in a denominator. A linear equation does not contain variables with exponents other than 1, so its degree is always going to be 1. And the graph of a linear equation is always a line. Okay, so linear equations, if we were to graph them, we would always graph a line. Okay, you have some examples here of linear equations. 4x minus 5y equals 16. X equals 10 is linear. Y equals negative 2/3 x minus 1, also linear equation here. Some examples of nonlinear equations. We have there on the right, we have 2x plus 6y squared equals negative 25. Alright, so if we were to solve that for y, we would be square rooting x. Okay. Here on y equals the square root of x plus 2. Okay. Nonlinear. In this third example, you see x is being multiplied by y. We're not able to do that. And then in this last example, you see y equals 1 over x. Again, a variable is not allowed to be in the denominator for linear equations. So we'll continue on. We'll talk about linear functions. It's a function with ordered pairs that satisfy a linear equation. Any linear function can be written in the form f of x equals mx plus b, okay, where m and b are real numbers. Okay, it's also useful to note m is equal to your slope for a line. B, we know that as our y-intercept. Okay, this is just allowing us to use the f of x, that function notation we talked about there towards the end of class yesterday. Alright, so example 1, state whether each function is a linear function, right? Yes or no. Explain. Alright, so we want to be able to write it in the form f of x equals mx plus b. If we're able to do that, then we have a linear equation. This first one just takes a little bit of manipulating. Okay. This is a positive 8, so we could rewrite this as f of x equals negative 3/4 x plus 8, where your slope, your m, is equal to negative 3/4 and your y-intercept value is equal to 8. So this is a linear function. Yes, we are able to write it in that form, y equals mx plus b. That is linear. Okay. Example B here, let me scroll. Would we be able to write that in a linear form, y equals mx plus b, or f of x equals mx plus b? No, we would not be able to. All right, this one, clearly we have an x, so this is not linear. No, not linear. And to explain that, x is in denominator. And I'm going to run out of room. Denominator. All right. G of xy is equal to 3xy minus 4. Again, this one is not linear. Okay. Not linear. We have two variables being multiplied. They're manipulating each other. The variables here, x and y, are manipulating each other. Multiplying each other, being manipulated. Alright, and spelled right at the same time. Alright, so I'll allow you time to go ahead, pause the video, check out 1A and 1B. Alright, so go ahead and pause and do both of those on your own. I'm going to scroll so that you're able to see 1B there. Alright, so you should have paused, and after you paused, you should have realized that 1A is not linear. Again, you have x is in the denominator. And you are able to get 1B into, well, in fact, it's already in the linear form. So this is, yes, it is linear. And it's in the form y, or f of x equals mx plus b, where m is equal to -3/2 and b is equal to 1/3. Alright, so let's go on then to the next page here. Example 2. We will be, okay, so example 2, we're going to be evaluating a linear function. The growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9 x plus 3.25, where f of x is the total height in inches, x days after an initial measurement. How tall is the sample after 3 days? So x represents days in this example here. X represents days. So if we were asked how tall it is after 3 days, we are substituting. This is going to give us x equals 3. Okay. And we're going to look at the height of the grass. So we want to evaluate f of 3. So we're substituting in 3 for x. So we do that. 5.9 times 3 plus 3.25. Alright, we do a calculator here. You should be doing the same. We multiply 5.9 times 3, and that's going to give us 17.7 plus 3.25. Add those two together, and we should get 20.95. F of 3 equals 20.95. Okay, in the context of this problem, how tall is the sample after 3 days? You could say after 3 days, the grass, of course I'm running out of room again, okay, is 20.95 inches tall. Excuse me, inches tall. 20.95 inches tall. So after 3 days, the grass, I'm going to go ahead and erase a little bit of what I've written here. Alright, so I'll rewrite that. So after 3 days, the grass is 20.95 inches. Alright, so part B. The term 3.25 inches in the function represents the height of the grass when it was initially measured. The sample is how many times as tall after 3 days. So we want to see how much taller it is. We want to take our measurement of 20.95. Sloppy 5 there. So 20.95. And we want to divide it by the initial height, 3.25. And again, with your calculator, 20.95 divided by 3.25 is going to give you 6.446. So we'll round to 6.45. Okay. So again, in the context of the problem, the grass is 6.45 times as tall after 3 days. All right. So we're going to continue on then with the notes here. Go on here to talk about the standard form of a linear equation. The standard form of a linear equation is ax plus by is equal to c, where a, b, and c are integers. Okay, a, b, and c are integers, so no fractions. Okay, with a greatest common factor of 1. Okay, a must be greater than or equal to 0. That means a must be positive, and a and b are not both 0. So a and b are not both 0. Alright, so an example of an equation in standard form we have here, 3x plus 5y is equal to 12. Of course, a is 3, b is 5, and c is 12. So example 3 here, I'm going to scroll a little bit. In example 3, we have the standard practice using standard form. We need to write negative 3/10 x is equal to 8y minus 15 in standard form. Identify a, b, and c. Again, we want a to be non-zero, and we want a to be greater than or equal to 0, so positive, non-negative. And we also want a and b both on the same side. So first thing we need to be doing is to subtract 8y from both sides. That will give us negative 3/10 x minus 8y. We're just moving the 8y here to the left side, is equal to negative 15. Alright, so next we would like to get the negative 10 out of the denominator. Okay, so what we need to do is multiply everything by a factor of negative 10. Okay, it's going to cancel our denominator. Okay, so that gives us 3x plus 80y is equal to 150. Okay, and now we should have this in standard form if we just look above here. Make sure we've got this, applied all the rules here. A, b, and c are integers. Okay, that's why we had to clear the fraction. A was not an integer. So we cleared the fraction by multiplying by negative 10. The greatest common factor of a, b, and c is 1. That is accurate. And a is greater than or equal to 0, so a is positive. Okay, not negative, and that is true as well. So we have it in standard form, so we have identified a, b, and c. A is equal to 3, b is 80, and c is equal to 150. Alright, moving on. I'll go ahead and let you guys practice with this. You want to get both of these 3a and 3b into standard form, so go ahead and pause the video. Give yourself a minute to practice these. Okay. Alright, so after you had an opportunity to practice those, okay, here's what these should have looked like. We should have been, in 3a, we should have been moving the 4x to the left by subtracting 4x from both sides. That would give us negative 4x plus 2y is equal to 5. Okay, we're almost in standard form. We do need a to be non-negative, so we need to get the negative out of there. We can do that by multiplying everything by a negative 1. When we do that, that gives us 4x minus 2y is equal to negative 5. So now our a is non-negative. Okay. A, b, and c, all integers, and the greatest common factor amongst them is 1. Okay. So we have standard form. A is equal to 2. Excuse me, a is equal to 4. Is equal to 4. B is equal to negative 2. And C is equal to negative 5. Alright, with the next one, what we should have been doing, we just added 9 to both sides. That would give us 3x minus 6y equals 9. Alright, so a is non-negative. That's good. A, B, and C are all integers, okay? But we do have an issue with the greatest common factor of A, B, and C is greater than 1, okay? If you look, you can see that a factor of 3 can come out of all of these. So in order to get rid of that, we just divide everything by 1/3. That will give us x minus 2y is equal to 3. Just divided each term, multiplied by 1/3, excuse me. Divide each term by 3. That gets rid of our factor of 3 in all of those. Now the greatest common factor of all 3 of these terms is 1. And so now we're able to identify A is equal to 1, B is equal to -2, and C is equal to 3. So this is the standard form here. All right. So let's continue on then. To work here. A little rocky. This is the first time I'm using this piece of technology here. So just bear with me, folks. All right. Since 2 points determine a line, one way to graph a linear function is to find the points at which the graphs intersect each axis and connect them with a line. Okay, we're able to graph a line if we have 2 points on that line. We just connect the dots, and then we have our line. So the y-coordinate of the point at which a graph crosses the y-axis is called the y-intercept. Likewise, the x-coordinate where it crosses the x-axis is called the x-intercept. Okay, so what we're going to do is we're going to be using the intercepts to graph a line. Okay, so example 4, find the x-intercept and the y-intercept of the graph of 2x minus 3y plus 8 equals 0. Then graph the equation. Okay, this will be useful to get this one into standard form first. To do that, we need to take 8 away from both sides. 2x minus 3y is equal to -8. Alright, so the x-intercept is the value of x when y is equal to 0. Okay, that's when we are crossing the x-axis, is when y is equal to 0. So we need to substitute 0 in for y into our standard form here. What that looks like is 2x minus 3, we're substituting 0 for y, is equal to -8. Okay. Alright. So, we're trying to find the x-intercept again of this example 4. Apologize, I had to take a pause there. Nonetheless, we've plugged in 0 for y. Now we're going to solve this equation for x. This gives us, mode here. 10. Alright, here we go. So this should give us 2x is equal to -3 times 0 is going to cancel out for us. So then -8. We divide both sides by 2. And we've got x is equal to -4. Okay, that'll give us the point on our graph. The ordered pair, -4, 0. That is the x-intercept. Okay, so that'll be useful when we go to graph this thing. Now we need to find the y-intercept. We're going to be doing the same type of deal here. Find the y-intercept. Okay, the y-intercept is the value of y when x is equal to 0. So we use our standard form 2x minus 3y. This time we're substituting 0 in for x. So 0 minus 3y is equal to -8. It's going to cancel out, of course, so we need to divide both sides by -3, giving us y is equal to 8/3, positive 8/3, which on your calculator, if you want to change that to a decimal, you're welcome to. That will give you 2.67. So we have the point -4, 0, and now we have the point 0, 2.67. That'll be our y-intercept. So to graph this thing, I'm going to do that over here on the left. Get my coordinate plane here. Okay. I got -4, 0, so -1, 2, 3, 4, -4, 0. Point there. And then I've got 0, 2.67. 2.67, of course, is occurring between 2 and 3. There's my y-intercept where I'm intersecting the y-axis. We'll see how this goes. We should be connecting those 2 points. Hopefully your straight edge is better than mine. Okay. Connect those 2 points, and now we have graphed that line using the intercepts. Okay. You guys are welcome to do that here. Take a pause. Go ahead and do that on this guided practice number 4 here. Okay. I'm going to go ahead and scroll down. I'll show you what that would look like here with number 4. So again, we need to be substituting in to find the x-intercept. Okay, we should be substituting in 0 for y. We also should have gotten this to standard form, 2x plus 5y is equal to 10. So to find the x-intercept, we're substituting, this is when y is equal to 0. So we're going to substitute 0 for y. 2x plus 5 times 0 is equal to 10. So this 2x equals 10. Divide both sides by 2. We should get x equals 5. So you have the point 5, 0. Similarly, you should have found the y-intercept. That's when x is equal to 0. So now we get 2 times 0 plus 5y equals 10. Cancels. Gives us 5. Divide by 5, excuse me. So here's y is equal to 10 over 5 is 2. And now we've got the point 0, 2.
Mrs. Hawk to the front office, please. Mrs. Hawk to the front office.
Alright. Move my little record there. Now we need to graph this. So we should have our x and y axis there. We got 0, 2 as our y-intercept. And 5, 0. So 1, 2, 5. And we should be able to graph this line again. Use a straight edge to connect the 2 points. You should have a line that looks like that. Alright. So that'll conclude your notes for the day. You should go ahead and pull out your homework and go ahead and get busy on that. Have a great afternoon.